Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the pass transistor logic concept in the combinational logic circuits. So the brief history about the circuits, CMOS gate design and pass transistor logic, and the next topic we will discuss transmission gate logic. So first the brief history about the transistors. We already discussed about the large scale integrator and small scale integrator SSI, medium scale integrator, very large scale integrator, and ultra large scale integrator. Based on the transistors connections, we decided to level the integrated circuits. So the flip-flop means it is using two transistors and it's built by Jack Kilby by the Texas Instruments, and the Intel Pentium, that 4 microprocessor, that is decided 512 megabit DRAM, and it's very faster, lower in power and smaller in cheaper. So according to the VLSI design principle, the three concepts are mainly considered. One is speed. Based on the RAM capacity, we can decide at the speed, and another one is area. We can use the lesser area, that is compact in size, and third one is power. So we can use the power, that is static power and dynamic power. Next topic we will discuss. So the annual sales, it is increased based on the year and the global semiconductor billings. So it is gradually increased from 1980 to 2002. And next to the transistor types, we decided the bipolar transistor. So in the name itself, it has the reason. Bipolar means the two poles it has. So one is NPN, another one is PNP. If NPN means both side N transistor is connected, in between you connected the P transistor. And PNP means that is in both sides you connected the P transistor, and in between N transistor is connected. So the small current into very thin base layer controls the large currents between the emitter and collector. So in bipolar, emitter, base, collector, it is used. For example, common base means the base terminal will be used commonly between input and output. So only it is called common base. Or common collector means collector terminal is connected between inputs and outputs commonly. So it is called as a common collector. Like thing emitter also. So the base current limit the integration density. And next we are going for metal oxide semiconductor field effect transistor, that is MOSFET. So for MOSFET we are using the NMOS and P MOSFETs. NMOS means if you are given the input 1, the NMOS will be working. If you given the input 0, the PMOS will be working. So PMOS is connected in the VDD level and NMOS is connected in the ground level. And next, the voltage applied to the insulated gate control between the source and drain, like the tap. So the tap conditions. So tap means that is gate level, and in one side means that is called the drain. Another level is called the source. So based on the gate voltage, we can control the current between source to drain or drain to source. So the low power is allowed only for the very high integration. So this is the CMOS NAND gate, that is NOR gate 4 inputs. So NOR gate means, how can you say this NOR gate means the NMOS is connected in parallel. If NMOS is parallel, PMOS is series. And the series parallel connection, that is very important for pass transistor logic. If the NMOS is 1, then it will be on. If PMOS is 0, it will be on. So if the both series, that is both are series, that must be on. If parallel means either one is on. So that is the conditions. So look at this. So this is the PMOS transistor. Bubble means you are mentioning the PMOS transistor, or without bubble means it is called the NMOS transistor. So based on the conditions. So you give the first transistor A, that means 0 0. If you are given the 0 0 means it will be off. If 0 1 means it is also off because it is in series condition. If 1 0 means it is also off because first one is that is connected and second one is not connected because that is NMOS. So already I told NMOS means if you given the input 1, it is enable. And the last circuit, look at this last one. So it is 1 1. So 1 1 means both must be on, that is serious condition. So both must be enable, so the output will come. And same thing for another thing, look at the B first one, 0 0 combinations. So 0 0 means both are 0, though it is enable, because already I told PMOS will be 0, means if we are given the input 0 means PMOS is enable. So both must be 0 means N is enable, so the output will come. If any one is 1, the output will not come, that is PMOS. And next, the both in parallel conditions. If parallel condition means any one is enable, it will be on. If anyone is not enabled, it will be off. So look at this first, 0 0 means both are not enabled, that is open condition, so it is off. Another one is 0 1 means right side is enabled, so output will come. So just imagine if it is connected the pipe in parallel condition, you just drop water on the top side of the pipe connection. So parallel condition means if any one pipe is closed, it means another side the output, that is water, will come. So this is a simple example for the parallel connections. And next, the conduction complement. So you can see the conduction complement. So the complementary CMOS gate, that is NMOS in series and PMOS is parallel, that is for the NAND gate. And the rule of the conduction complement, the pull-up network is complement pull-down. So parallel series or series parallel is vice versa. Next, the complement gate, you can use the AND OR inverter. So this is the main application of the logic. So look at this, and OR, that is AB plus CD. So AB means that is NAND gate. NAND gate means what? That is NMOS is series. If NMOS is series means, so you look at this connection, AB, CD, both are series. So it is joined together. That is B will come. So option A, that is converted into option B. Next, C means if AB is series, then PMOS, that is parallel. If CD is series in NMOS and CD is parallel in PMOS, so it is a combinations. Then you can add B plus D, you can get the E. That is called the AND OR inverter, that is using the compound gate logic. So this is R3 AND inverter, that is inversely proportional to the previous one. So the strength of the signal, how it is closed, that is very important. Based on this, we can get the weak 1 or degraded 1 or degraded 0 or weak 0, you can get. So the NMOS pass strong 0, that is degraded or weak 1. If PMOS pass strong 1, that is degraded or weak 0. So thus NMOS is the best for pull down network. So normally we are using NMOS comparatively PMOS. So this is the pass transistor, it can act as a switch. So if G is 0, then it is open. If G is 1, then it is closed. So the output will come between the source and drain. And same thing for PMOS logic. If G is equal to 0, the input is connected between the source and the drain. So the output will come. That is, output is degraded 0. If the input, that is gate input, G is equal to 1, then it is open. So it passed the transistor. That is, it is not enable. And next, if the output is G is equal to 0, it passes the strong 1. So this is the concepts of pass transistor logic. Next topic, we will discuss about the transmission gates.